Hello student, this is the 8th lecture on applications of derivative. In this lecture, I will complete 10 examples. Important concept and formulas, tangents and normal. This is the equation of the tangent and this is the equation of the normal. We have completed 50 examples on equation of the tangents and normal in previous lecture. Okay, now in this lecture, we will study examples on derivative as a rate measure. Okay. First example. The age of a cube is decreasing at the rate of 0.6 centimeter per second. The rate at which the surface area is decreasing when the age of cube is 12 centimeter is. First option 86.1 centimeter square per second, B 86.2 centimeter square per second, C 86.3 centimeter square per second and D 86.4 centimeter square per second. Now here we have given that the age of the cube is decreasing at the rate of 0.6 and we want to find out the surface area at which it is decreasing. Okay, now here let x be the age of cube and s be the surface area. The total surface area of the cube s is equals to 6x square. Therefore, differentiate this with respect to t. Therefore, ds upon dt is equals to 12x into dx upon dt. Substitute the value of x, that is x is a 12. 12 into 12 and the value of dx upon dt is 0.6 and their multiplication is 86.4 centimeter square per second and hence option D is correct here. Next example. A square plate is contracting at the rate of 2 centimeter square per second. The rate at which the perimeter is decreasing when the side of square is 16 centimeter long is first option A 4 centimeter per second, B minus 1 by 4 centimeter per second, C 1 by 4 centimeter per second and D minus 4 centimeter per second. Now the solution. Let x be the side, p be the perimeter, a be the area of the square. आता इथे आपल्याला काय दिलेलं आहे की त्याचा एरिया 2 सेंटीमीटर स्क्वेअर पर सेकंद ने तो कॉन्ट्रॅक्ट होत आहे अँड वी वॉन्ट टू फाइंड आउट द rate at which the perimeter is decreasing. Means what? We want to find out the perimeter in terms of area. Therefore, p is equals to 4. But what is the value of x? X is the root of a. Therefore, p is equals to 4 into root of a. Now, differentiate this with respect to t. Therefore, 4 into derivative of root of a is 1 upon 2 times root a into dA by dt. Okay. And after simplification, you will have 2 upon root of a into dA upon dt. Okay. And hence, we have here that is a 2 upon x. Okay. Okay. What is the value of root of a? Root of a ची value इथे किती येणार? Taking the square root on both sides, then you will have root of a is equals to x. म्हणून या root of a च्या ठिकाणी आपण इथे x लिहितोय. 2 upon x into dA by dt. Okay. Therefore, substituting the value of x, x is equals to 16 centimeter. dA upon dt is 2 centimeter square per second. And hence, after simplification, you will have 1 by 4 centimeter per second. And hence, the required option is a C, which is 1 by 4 centimeter per second. And hence, the perimeter is decreasing at the rate of 1 by 4 centimeter per second. Now, the next example. Let V denotes the volume of sphere and S is its surface area. Then the rate of change of V with respect to S when the radius of sphere is 2 centimeter is. First option A is 1, B is 2, C is 3, D is 4. Okay. Let R be the radius, S be the surface area, V be the volume of the sphere. S is equals to 4 pi r square, V is equals to 4 by 3 pi r cube. We want to find out the rate of change of V with respect to S. Therefore, dV upon ds is equals to dV by dt upon ds upon dt. Now, derivative of this volume with respect to t is 4 pi r square into dr upon dt, and the derivative of this surface area is 8 pi r into dr upon dt. Okay, now here dr by dt get cancelled, pi get cancelled. 4 upon 8 means what? 1 upon 2. R square upon R means what? R by 2. Substitute the value of R2, then you will have 2 by 2, that's equals to 1. And hence rate of change of V with respect to S is 1. And hence option A is correct here. Next example. The surface area of a sphere increases at the rate of 0.6 centimeter square per second. The rate at which its volume is increasing when its radius is 10 centimeter is, first option is a 2 cubic centimeter per second, 3 cubic centimeter per second, 4 cubic centimeter per second, and 5 cubic centimeter per second. Okay, now see this here. Let R be the radius, S be the surface area, and V be the volume of the sphere. S is equals to 4 pi r square, V is equals to 4 by 3 pi r cube. Okay. ds upon dt is 8 pi r into dr upon dt. dv by dt is 4 pi r square into dr upon dt. Okay. And therefore here dv by dt, we will express this dr by dt in terms of ds upon dt, because we have given the surface area of the sphere increases at the rate of 0.6 centimeter square per second. Therefore, dr by dt is equals to 1 upon 8 pi r into ds upon dt. And hence, dv by dt is equals to 4 pi r square into 1 upon 8 pi r into ds upon dt. And after simplification, you will have your r upon 2 ds upon dt into ds upon dt. Okay, what is the value of r? R is 10, 10 by 2, ds upon dt is 0.6, and hence the answer is 3 cubic centimeter per second. Okay, and hence option B is correct here. Next example. Now the next example is the distance traveled by a particle moving in a straight line in time t is s is equals to in root of at square plus bt plus c. Then the acceleration of the particle is proportional to first option t, second b is s, c is s raised to minus 3, and d is s raised to minus 3 by 2. Okay, now see this here. Solution: s is equals to in root of at square plus bt plus c. Now differentiate this with respect to t. Therefore, v is equals to velocity v is equals to ds upon dt. Now the derivative of in root of at square plus bt plus c is 1 upon 2 times in root of at square plus bt plus c into derivative of at square plus bt plus c, and that is 2at. Derivative of bt is a b, derivative of c is 0, and hence you will have here that is a 2at plus b upon, again the value of in root of at square plus bt plus c is s. Therefore, velocity v is equals to 2at plus b upon 2s. This is the first one. What about the acceleration? We want to find out the acceleration. Therefore, dv by dt is equals to, now here we apply the quotient tool. Okay, now here 2s into derivative of 2at plus b. The derivative of 2at plus b with respect to t is a 2a minus 2at plus b as it is, and the derivative of 2s, that is a 2 into ds upon dt upon 2s square, which is the 4s square. And the next simplification, that is a 2 into 2, that is a 4as minus 2 into ds upon dt. The value of ds upon dt, here is the value of the ds upon dt, that is a 2at plus b upon 2s. And after substituting and the multiplication, then you will have here 280 plus b into 280 plus b upon 2s. This 2 get cancelled, and then after simplification, s into s, you will have the s square, that is a 4as square. But what is the value of s? S is equals to in root of at square plus bt plus c. Therefore, s square is a at square plus bt plus c. Substitute the value of s square, and after this multiplication, and this 2s is again will divide multiplied with this 4s square, then you will have 8s cube, and after the simplification you will have 4 AC minus B square upon 8s raised to 3, and therefore the acceleration is A, C, B, these are the constant, and therefore the acceleration is proportional to s raised to minus 3, and hence option C is correct here. Now the next example, you can see this also here. Example number 6. A spherical snowball is melting so that its volume is decreasing at the rate of 8 cubic centimeter per second. The rate at which its radius is decreasing when it is 2 centimeter. The first option is a 2 pi centimeter per second, B is 1 upon 2 pi centimeter per second, C is 1 upon pi centimeter per second, D is a pi centimeter per second. Okay. Now here, let R be the radius and V be the volume of the sphere. V is equals to 4 by 3 pi r cube. dV by dt is equals to 4 pi r square into dr upon dt. Now substitute the values. That is the rate of decreasing the volume is 8. Therefore 8 is equals to 4 pi, the value of r is 2, that is a 2 square, into dr upon dt, and the after simplification we have the value of dr upon dt, which is equals to 1 upon 2 pi centimeter per second. Okay, and this is the answer, that is option B is correct here. That is the rate at which the radius is decreasing when it is 2 centimeter is 1 upon 2 pi centimeter per second. Next example. The radius of spherical balloon increases at the rate of 4 centimeter per second. The rate at which its surface area increasing when the radius is 5 meters is, first is 160 pi centimeter square per second, B 1600 pi centimeter square per second, C 16,000 pi centimeter square per second, and the D 16,000 centimeter square per second. Okay, now the solution. Let R be the radius, S be the surface area of the sphere, S is equals to 4 pi r square, ds upon dt is 8 pi r into dr upon dt, therefore 8 pi, and the substitute the value of r is 5 meters, means what, 500 centimeter, dr upon dt we have given it is a 4, and after simplification you will have 16,000 pi centimeter square per second, and hence the option C is the correct here, that is a 16,000 pi centimeter per second. Okay, next example. The radius of circle is increasing at the rate of 2 centimeter per second. The rate at which its circumference is increasing when radius of the circle is 5 centimeter is 2 pi centimeter per second. Next is 3 pi centimeter per second. C is 4 pi centimeter per second, and D is pi centimeter per second. We have given the radius of the circle increasing at the rate of 2 centimeter per second. Okay, now here we have given dr upon dt. This is the dr upon dt is equals to 2 centimeter per second, and we want to find out the rate at which the circumference is increasing. What about the circumference of the circle? C is equals to 2 pi r. Now differentiate this with respect to t. Therefore dc upon dt is equals to 2 pi the derivative of r with respect to t, and now substitute the value of dr upon dt, that is equals to 2 pi dr upon dt is 2. Okay, and overall you will have their multiplication 4 pi centimeter per second. Okay, and hence option C is correct here. Easy example ಇದೆ, option C ಇದೆ correct. Next example. The radius of a circle is increasing at the rate of 0.5 centimeter per second. The rate at which area of the circle is increasing when the radius is 2 centimeter is 2 pi centimeter square per second. B is a minus 2 pi centimeter square per second. C is 1 upon 2 pi centimeter square per second. And D is a pi centimeter square per second. Okay. Now the solution. Let R be the radius. A be the area of the circle. A is equals to pi r square. dA upon dt is equals to 2 pi r into dr upon dt. Okay. Now substitute the value. 2 pi. The value of r is 2. dr upon dt is 0.5. Okay. And after the simplification, you will have here 2 pi centimeter square per second, and hence the option A is correct here, that is a 2 pi centimeter square per second. Now the next is the equation of motion of two stones thrown vertically upwards simultaneously are S is equals to 19.60 minus 4.9 t square and S is equals to 9.8 t minus 4.9 t square respectively. The maximum height attained by the first one is h. When the height of the first stone is maximum, the height of the second stone will be. Now here, when the first stone reaches the maximum height, its velocity is 0. At that time, we will find out the value of the t. Therefore, here s is equals to, for the first stone, 19.60 minus 4.9 t square. Therefore, velocity v is equals to ds upon dt, that is a 19.6 minus 4 9.8 into t. At maximum height, v is equals to 0. Okay. And after simplification, this you will have t is equals to 2. When the first stone is at maximum height, then what about the second height of the second stone? Now we have the s is equals to, for the second stone, 9.8 t minus 4.9 t square. Substitute here t is equals to 2, and after simplification you will have here 9.8 into 2 minus 4.9 into 4 is equals to 0, and hence the height of the second stone will be 0. That is option D is correct here. And in this way we have completed here 10 examples. Now we will see in the next video. Till then, goodbye.